All right, hello everyone. Let's get started. So today's topic is 3D geometry, and I have some questions prepared for you. Hopefully, you'll enjoy the wonderful world of 3D geometry. So let's get to it. So first thing, we are talking about cross sections, and suppose you have a shape, a 3D shape, and you want to slice it. You want to slice it with a plane. And the plane, as a matter of fact, the plane passes through these 3 points, K, T, and M. So, of course, there's going to be a straight line going through T and K. Ah, this is awkward. Okay. And then there's going to be a straight line going through so TM. And then this plane is going to cut the well, it won't slide. Basically, you cut off a slice of the prism. So how does it go? Well, because it's a right angled prism, right? So it's an you can draw a line parallel to KT. Well, the problem is you don't know whether KT is parallel to AA1. Okay. And what else can you do here? You draw a line parallel to TM through point K. So you construct a line, let's call it KK1. KK1 is parallel to TM. And that gives you the third point of intersection. And then you join that point with M. And let's call this TML. So KLMT is the cross section. I hope that makes sense. So this is one of the ways you construct a cross section. Do you understand this problem? Let me know on a scale of 0 to 10, please. Okay. Some more votes. Now, you can't. LM is not going to be parallel to TK. Right. So my first instinct was, but if TK was parallel to AA1, then yes, they would be. But TK is not parallel to AA1, and so TK is not parallel to LM. Therefore, we can't use that line, but we can construct KK1, which is parallel to TM, and then we can build the cross section. Let's have a look at the assignment. Okay. So here you need to do some very similar problems. Suppose I'm going to do one more. I'm not going to do this one. That would be unfair. But let's take the third point to be here rather than here. Okay. So, but LM is not parallel to TK. Because why would it be? Why would it be? You can consider like a slightly more extreme case. Like let's move T slightly to the left. Let's say T was here and TK was like that. So you can clearly see it's actually impossible to draw a line parallel to TK. Well, there was no KL to begin with. I just draw KK1, a line. So KK1 is parallel to TM. Why do I know this? Well, because the plane ABC is parallel to the plane A1, B1, C1, and if you slice, if you have two parallel planes, and you have a third plane slicing two planes, then the intersection would be parallel lines. So if a third plane cuts two planes, so a plane cutting parallel planes. Plane cutting two parallel planes. Yeah, I'm using this rule. Okay, slightly better picture than the one that I have drawn. So yes, if you have two parallel planes and a third plane cutting two parallel planes, then the two lines of intersection would be parallel. So AB is parallel to CD. The same way, here we have KK1 is parallel to TM. And then KK1 meets A1B1 at point L, and that's our cross section. Okay. Let's do another cross section here. So it goes, so it's a plane cutting like this. Okay, so that's the first line. And then there's this line. Now, what can we do here? Well, let's find where this let's extend the bottom plane, the base plane. So we extend this line, and we extend this line. This is where they meet. Okay. So this is where, let's K, L, M, M, N, K, L, M, N, O, let's say P. P is where line LK meets the line C, D, A dash, B dash, C dash, D dash. So AD meets LK at point P. Now point P belongs to the plane AD D1 A1. So point P is in that plane. Therefore, the line PM is also in that plane. PM also in that plane. AD D1 A1. And therefore, you can draw a line through PM. Sorry, Myro is not very good at drawing straight lines, so I'm just going to do my best. So you draw, and this is this point, KLMN. N is the meeting point of PM and A1, B1, C1, D1. Okay, so we've got another point. That's not enough because we're still missing. We're still missing where it meets the remainder of the points. But the top plane is parallel to the bottom plane. So LK, we draw a line parallel to LK. So NJ NJ is parallel to LK because the planes are parallel, so you're allowed to do that, NJ. Okay. All right, so now what happens next? Well, now you draw a line parallel to ML. So JG is parallel to ML. And finally, K and G are in the same plane, so that's your cross section. So a hexagon. Okay, harder than I expected, but yeah, doable. So basically you just extend the lines and yeah, you employ your 3D thinking. Something that is not developed in school for some reason. So yeah. Okay, moving on. So this is a plane cutting a sphere of radius r. Radius r. And a plane is drawn a distance a from the center. And the task is to find the area of the cross section. Okay. So, well, I think you can imagine what's going on. So you have a sphere and you're slicing it. So from the side view, it looks like this. This is the center of the sphere. This distance is a, and this is the radius of the sphere. And this, r, is the radius of the smaller of the circle of the cross section, r. So r is the radius of the cross section. Okay. Can somebody find an expression for r? Can you find an expression for r in terms of a and r capital? Very good. It is the square root of r squared minus a squared. Yeah, so and the area is going to be pi r squared, which is pi square root of r squared minus a squared. Okay. They might also ask you, no, that's fine. So yeah, that's the answer. So that's a simple one. And actually, 3D geometry is not that hard. It's just a matter of drawing it, imagining it, and finding a suitable right angle triangle, or at least a triangle. If you can't find a right angle triangle, at least find some triangle. Okay. The height of a cylinder is h. The radius is r. Okay, let's start drawing it. Does it do oh, it does cylinders. Okay, that's handy. The height of a cylinder is h. The radius is r. A pyramid is placed inside the cylinder. The height is AA1. So AA1 would be this. A1. I forgot the word for it. The line that produces the cylinder. If you think about it, a cylinder is produced by a line moving parallel to itself in circular motion. So that makes a cylinder. The height is AA1. The base of the pyramid is an isosceles triangle where AB is equal to AC. So you have AB, AC. So that's a triangle. And the pyramid is like this. Okay. Find the total area of the sides of the pyramid. If the angle A is 120 degrees, So that's 120 degrees. Find the total area of the sides of the pyramid. Okay. So to begin with, I'm going to draw the circle AB, the circle, the bottom circle. Circle. Or the base. So there's A. This is 120 degrees. This is B. This is C. Of course, it's 120 degrees. That means the center is here. And this is the radius. Now, if I draw an additional angle, so this is 120. If I were to draw a line like this would be a cyclic quadrilateral. So A, B, D, C is a cyclic quadrilateral. And that means angle D is 60 degrees. Angle D is 60 degrees, and that means that angle BOC is double that, because the central angle is double the angle at the circumference. So BOC is 120. Double. Double angle D. Okay, everything making sense so far? Do ask me if you are unsure. And so why am I doing that? Well, this is 120 degrees. Is that even possible? Of course it is. That means that BOCA is a rhombus. And therefore, AB is equal to AC is equal to R. That's quite cool. So that's R, and that's R. And that means that to find the volume of the pyramid, we don't need the volume, we need the total sides of the pyramid. Well, to find the sides of the pyramid, we also need to find BC as well. Okay. The area of the side. So BC, we can use, what can we use? Well, we can use many different. This is B, O, C, A. We can say, well, this is two equilateral triangles, because this is R, this is R, this is R, this is R, this is R. So to find BC, well, we can use, of course we can use cosine rule, but why would you use cosine rule if you can use just normal trig? So this is 30 degrees, and BC is 2 times R times cosine 30 degrees, which is 2R square root of 3 over 2. So it's square root of 3R. So BC is square root of 3R. What else? We can find the to find the area of A1BC. Can we find the center of BC? We certainly can. Let's call this point M. So M is the midpoint of BC. M is the midpoint of BC. And then we can write that AM, so this is M. M. So AM is R over 2, radius over 2, and it's obvious from this triangle because this is a rhombus with angles 120, 120, 60, and 60. So that is AM is R over 2, and this is the height of that triangle. So okay, R over 2. This height is H. So A1M, A dash M, A prime M is the height of the triangle, is the height of A1BC, and A1M, using Pythagoras theorem, is H squared plus R squared over 2, R over 2 squared, sorry, square root. So that's square root of H squared plus R squared over 4. And then the area of triangle A1BC is 1/2 times the base, which is BC, times the height, which is A1M. So 1/2 times BC, which is square root of 3 over R, square root of 3R, times A1M, so square root of H squared plus R squared over 4. Can we simplify this? Well, ish. Not dramatically. Square root of 3R over 2, square root H squared plus R squared over 4. That's fine. So area of triangle A1, A prime C, the second side of the pyramid, that is 1/2 base times height, and the base is R, and the height is H. And area of triangle AB A dash is the same because it's symmetry. Okay, so finally we have the answer. We need this area of this, the total area of the sides. That means it's RH plus root 3 R over 2 square root H squared plus R squared over 4. And that's the answer. Hope that makes sense. But I don't know if you've noticed that all I did is I was looking for triangles and trying to work out the sides of those triangles. Did you notice that? Please let me know. Did you notice that all I did in this question is looking for triangles and trying to work out the sides of these triangles using trig, using cosine rule, using any. It is. And 3D geometry always breaks down to that because there's not much you can do. There's a saying, fundamentally, if a problem cannot be written as a set of simultaneous linear equations, that means this problem is unsolvable. Okay? This is a conjecture, but it's certainly is true for any problem that I have ever did. If it can't be written as a set of simultaneous equations, then it's unsolvable. So simultaneous linear equations. Sorry, it's very specific, linear, no squares, nothing, just simultaneous linear equations. Okay. Yeah, they are, but you have to eventually break them down. When you solve a quadratic, you break it down into factors, and factors are linear. So you have linear factors, therefore it is a linear solution. It comes down to a linear solution. Okay. Problem 4. The base of a pyramid is an equilateral triangle of side A. One of the edges of the pyramid is perpendicular to the base and equal to B. Find the radius of a superscribed sphere. So this comes down to a good drawing, actually. So let's try to do this. A base of a pyramid is an equilateral triangle of side A. Okay, so an equilateral triangle. All right, not good enough. So I'm not drawing it as equilateral because I'm drawing it in 3D. I hope you can appreciate that. So this is an equilateral triangle side A. So this is A, and A. One of the edges of the pyramid is perpendicular to the base. Okay. And its length is equal to B. Find the radius of the superscribed sphere. So basically it is a sphere that goes like this. Okay. Well, for simplicity, I'm just gonna draw. I don't know if that it's going to be is actually going to be simple, but yeah. So here's the center of the sphere, O. Let's label this A, B, C, and let's call it D. So let's draw some lines. This is the radius. This is the radius. This is the radius. And this is the radius. Okay. Sorry, just a second. Just opening my notes. Mm-hmm. Okay, so let's draw a line. Let's draw a perpendicular from point O. We draw perpendicular downwards until we meet the plane ABC. And let's call this point K. So OK is perpendicular to the plane ABC, and K is in that plane, of course. K belongs to the plane ABC. And now we draw a perpendicular, like find a point E, and we draw a perpendicular from O to E. OE is perpendicular to AD. And because AOD is a is an isosceles triangle, that means E is the midpoint of AD. Because triangle AOD is isosceles, that means that E is the midpoint of AD. Hope that makes sense. In an isosceles triangle, if you draw a perpendicular, it's also the median. Okay, so OK is perpendicular to ABC, but because point O is equidistant from A, B, and C, that means K is equidistant from A, B, and C. O is equidistant from A, B, and C, and that means that K is also equidistant from A, B, and C. That means K is the center of mass, of triangle ABC. And that means that KC is 2/3 of KM. That means KC is 2/3 of KM, and KM is quite easy to find. So you draw, remember I said search for a right angle triangle, and that's one of your right angle triangles. So CMB is a right angle triangle. This is A, and this is A over 2. That means 2/3 CM, not KM. CM, and CM is square root of A squared minus A squared over 4, which is square root of 3 over 2A. So KC is 2/3 times square root of 3 over 2A. So that is square root of 3 over 3A. So we found KC. Now KO is equal to AKO is parallel to AE, and OE is parallel to AK. And we know that AE is perpendicular to the plane ABC. From all of this, I make a conclusion that AEOK is a rectangle. And that means that OK is equal to AE, which is a half of B. So OK is a half of B. And now we look at the triangle. Consider triangle KOC. So C, K, O. I know that OC is R. I know this is a right angle because OK is perpendicular to the plane. OK is B over 2. And KC we've already established. That's square root of 3 over 3A. And finally, using Pythagoras' theorem, Pythagoras, we find that R is equal to the square root of 3 over 9A squared plus B squared over 4, which is square root of A squared over 3 plus B squared over 4. And that is the answer. So if you manage to follow this, then again, I first did the isosceles triangle. Then I used the property that the midpoint is 2/3 splits the median in the ratio 2:1. So KC is 2/3 of CM. Then I used the Pythagoras theorem a couple of times to arrive to the answer. Okay. Problem 5. Ooh, there's not much left to do. Um, I'll pop this question on the board, and I'll answer it in a minute. Okay. Find the area of the cross section of a truncated pyramid, and also find the angle x. So the angle x is the angle between the base plane and the plane here. So this is 5 meters. This is 3 meters. So a very big pyramid. Truncated pyramid. Find the area of the cross section. Okay, so all we need is just to start looking for a nice right angle triangle. Or how about this one? I really like this one, because I think if we find something here, that would be nice. So let's call it A, B, C, D, E, F, M. Okay, so well, I can't really find anything yet. Okay, All right, so let's put another point. Let's call it point O. O is the center of triangle ABC. O1 is the center of triangle DEF. And let's continue. So imagine what was the pyramid like before we cut it. So we continue the lines. Okay. And let's this be S. So now we can draw the line S O1 O. That's O1 O. Okay. And now I can use the similarity of triangles. So if I draw can I use that? Just a second. No, I won't do that. I'm going to write this. I'm gonna look at this triangle SOC. Consider triangle SOC. Okay, so we know that this height is 3 meters. And we know that this is, well, this is not 8 and this is not 5, but they are in proportion of 8 to 5. Well, let's do it properly. So OC, already know, we know that OC, so this is OCS, this is O1F. We know that OC is 2/3 of CM, and we know that CM is square root of 3 over 2 times 8. So 2 cancels, it's 8 square root 3 over 3. 8 square root 3 over 3. And similarly, O1F is 2/3. Well, I'm just going to write down the result. So it's going to be 5 square root 3 over 3. 5 square root 3 over 3. And from the similarity, because triangle SO1F is similar to triangle SOC, and that means that the ratio of SO to SO1 is 8 to 5. And from here, so SO is SO1 plus 3 divided by SO1 is equal to 8 to 5. And here, so it's 5 arrow, it's an arrow, hence 5SO1 plus 15 equals 8SO1. So SO1 is 5. So this is 5, this is 8. So the height of the pyramid is 5. The height of the whole pyramid would be 5. Oh, sorry, 8. So this is 5, this is 3. And what does that give us? we can find that this is 3. And, oh, of course, if this is 3, we can find this side because they are proportional. 3 to, let's say, x. So this is x centimeters. Oh no, we already have x. No, can't use x. Apologies. Let's call it Cn. N. So triangle CNF is similar to triangle COS. Therefore, the ratio SO to OC is the same as FN to NC. So from here, SO is 8, OC is 8 root 3 over 3, is equal to Fn, which is 3, over NC. And from here, I can find NC is equal to 8 cancels, 3 cancels, and NC is root 3. Oh, that is nice. This is root 3. And if this is root 3, and we know that Mn is, Cm is root 3 over 2 times 8, and Cn is root 3, so that's 4 root 3. That tells us that Mn has to be equal to 3 root 3. Aha! So finally, we got somewhere. We found Mn. And now consider triangle MFN. So this is 3. So this is MFN. And this is 3 root 3. So we can immediately find angle X. So X is arctan 3 over 3 root 3. And that is 30 degrees. So X is 30 degrees. And the area, to find the area, we need MF. So area of triangle ABF, area of the cross section, is 1/2 AB times MF. Well, we know AB is 8, but we don't know MF, but we can find MF. MF can be found from Pythagoras' theorem as the square root of mn squared plus nf squared. And mn squared, that's 3 root 3 squared plus 3 squared. E squared. And that is 3 times 9, 27, plus 9, 36. Oh, is it? Is it? That's very nice. Very, very nice of them, of this pyramid to be 6. So MF is 6. That's really good. So the area of the cross section of the triangle ABF is 1/2 times AB, which is 8, multiplied by MF, which is 6. Whoa, so it's 24 square centimeters. Square meters. Beautiful. All right. So the answer. Oh, okay. So here's the answer. This, and here's the answer for that. quick question. If I gave you the exact same question right now, would you be able to solve it on a scale of 0 to 10? Exact same question on a scale of 0 to 10, please. Let me know. NC. Ooh, yeah, NC is tricky, but it'll take a while. Okay. Right. Well, it's, yeah. Okay. Ooh, that I like this one. So, A, B, C, D, A1, B1, C1, D1 is a cube. And DESK is a cross section where E is a quarter of the side. So if this side is A, then AE is a quarter of A, is A over 4. So this point is fixed, this point is fixed. But K is a random point. K is a random point, so K is allowed to move up and down effectively. And that also means that point S moves, because if K moves, then S moves as well. Okay, so K is not fixed and S is not fixed. And the question is, find the volume of the pyramid DESKA. So that is a pyramid. And we're supposed to find the area, or the volume, sorry. So it's not a square, it's a quadrilateral pyramid or something. I don't even think it's an, I don't even think it is a parallelogram. It might be not. It actually doesn't matter if it's a parallelogram or not. Okay. Well, what can we do here? It's, well, this pyramid, A D E S D E. Sorry, I didn't name it properly. D S K E A. DEKS. KS, but doesn't really matter. It's a cross section. K is a random point. Okay. Well, what we can do is we can break this pyramid into two pyramids. You can break pyramid D E K S A dash into two pyramids. D E A1 DEA1 S and SEA1 A dash K. Let's draw this. So this is the first pyramid. And this is the second pyramid. Okay. Does that make sense? Now, the volume of pyramid D, E, A dash S is the base is 1/3 base times height. So base is 1/3 then times the area of triangle D, E, A dash times the height. But the height of that pyramid is A, because the distance from S to the plane times A, because distance from S to the plane D, E, A dash is A, right? Can you see that the distance from S to the plane DEA1 is A, is the side of the pyramid, and therefore no, because these are two parallel planes. CB1C is a plane, and this is another plane. They're parallel planes, and the distance from S, it's in that plane. The distance from S to that plane is A, is equal to that distance. In a cube, the distance between opposite planes is A, and the distance from any point to the opposite plane is also A. The distance from S to the plane is A. So the height of the pyramid, so if you were to place the pyramid on the side, it will be the height of that pyramid would be A. Okay. And all we need to find the area is the area of triangle DEA1. Consider the triangle DEA1. So it looks like this. This is D, this is E, this is A', and this is A/4, so this is 3/4 A, but the height of that triangle is also A, because the distance from point D to line A1 is also A. That's the height of the pyramid, because after all, it is a part of a square. So that side is A. And therefore, that area of triangle DEA1 is equal to 1/2 base times height, 1 times 3/4 A times A. So that is 3/8 A squared. Ooh, nice. We're getting somewhere. So the volume of the pyramid DEA1S is 1/3 base times height. So 1/3, so that is equal to 1/3 times 3/8 A squared times A, which is A cubed over 8. Now consider the pyramid EKSA1. Consider, let me change color. consider now consider pyramid SEK dash. Consider the second pyramid. And so the height of that pyramid, so the base is triangle EK. No, that won't work. Oh yeah, it will. EKA1 EKA1 is the base of that of the pyramid, and the height is, well, it's this line, so is A. Height is A because the distance from S to the plane, distance from S to plane A, B, B1, A1. Abba. Is the distance from S to the plane. Okay, and once again, the triangle E the height is A. Is that what you're asking? Okay. So look at the EA1K. It's a triangle. Let's just draw it in a different way. Suppose this plane, this side, is A, B, A1, B1. Yep, so this is a square. A1, B, A, B, B1, A1. Oh, okay. So E is here. E is here. And S is above BB1. So S is somewhere here. S. But S is in a parallel plane. And the distance from S to that plane has to be A because it is a. And so S is here and it's in that plane. S is in the parallel plane. And the distance from S to the bottom plane is A, which is the side of the square. And yeah, so that's about it. And now when the volume of the pyramid EA1 K K K is somewhere here. K, the volume of the pyramid. So this is the pyramid. This is the pyramid. Is the base times height. So area of triangle EKA dash EKA dash, well, it's 1/2 base times height. It's 1/2 times 3/4 A times height, which is also A, which is 3/8 A squared. And the volume of the pyramid SEKA dash is 1/3 times base, which is 3/8 A squared, times height, which is A, which is A cubed over 8. So the total answer, the volume is A cubed over 8 plus 8 cubed over 8. That's A cubed over 4. That's the final answer. Okay. I hope that makes sense. Now, so there's a question about limits, slightly unrelated, but I'll answer that. Well, 0 times ln 0 is in any book, 0 times ln 0 is undefined. If you stick it into your calculator, 0 times ln 0, it's a math error, is undefined. But that doesn't mean it doesn't have a limit. But the limit of x multiplied by ln x as x tends to 0 is in fact 0. Okay. So how can we prove that? So even though ln 0 is technically negative infinity, and this is technically 0, this is true. How can we prove it? You could, yeah, you could prove it using the Maclaurin series. Yes. Thank you. Yeah, Maclaurin series, but Maclaurin is not very good with ln x, is it? No, sorry, no, you can't use Maclaurin because Maclaurin of ln x, you don't have Maclaurin of ln x because this goes to infinity. You could say, okay, it's equivalent to limit. So let's make a substitution. U is equal to 1 over x. So limit of x times ln x yeah, x tends to 0 is equal to the limit of 1 over u multiplied by ln 1 over u as u tends to infinity. Okay, so that will be limit u tends to infinity of minus logarithm u divided by u. But we know that u is a stronger infinity than ln u. Okay, so we know that yeah, we know that this is equal to 0. So that's how I would prove it. Maybe there's an easier way. Uh, you well, you can easily prove that, because if you make a series, ln u divided by u is, yeah, is 0, because u is a stronger infinity than ln u. Okay, so I hope that makes sense. Um, right. So yeah, does that make sense? It's still undefined. 0 times ln 0 is undefined. It's not possible, but it does have a limit, and the limit is 0. Okay. All right. See you all. Like, even if you do x over x, like x squared over x. Oh, sorry, x over x. So technically it's always 1. But if x is 0, that doesn't exist. Still doesn't exist. Okay. Yeah, go for it. Question about the physics assignment? Example 2, it says that the current induced in AB would have a positive pole at A, but the current induced in C would have a positive pole at C. Why does it flip? Oh, that's a good question. Let's have a look. Example 2. Current induced in B would have a positive pole at A, but the current induced in CD would have a positive pole at C. What? B is parallel to the. Okay, so let's see. So CD, let's take a negative. So you have the field, current, force, positive. So for CD, the negative pole is at D and positive at C. And same for B. Yeah, it is. Sorry, we must have made a mistake. With the positive pole at B. Yeah, sorry. Thank you for pointing that out. I will correct that, and for future versions, we will. Yeah. No, no, it's a function of x, but it just increases. Yeah. Can you draw what? Can you draw what angle pi over 2 minus theta is? Well, if you have an angle theta, if you have a right angle triangle, and this is theta, then this angle is pi over 2 minus theta. So literally 90 minus theta. Which, oh, here, sorry. Yeah, so silly. Forget what I said. Uh, okay. Line CD. The magnetic field is directed to the plane, to YZ plane at angle theta with respect to the normal of the frame of the diagram. Okay. Y Z plane is directed parallel to the YZ plane at an angle theta. So if you were to draw CD, so if you draw Y going down, Z going to the right, and X going towards you, then DC would look like this. DC would look like this. And B, the lines, magnetic field lines, are going at an angle. Magnetic field lines are going at an angle like this. B. Now, the angle between the magnetic lines and the normal to the plane of the frame. So this is the normal to the plane of the frame, and this angle is theta. And that means that DC, this angle, is pi over 2 minus theta. Does that Does that clear things up? Okay. All right. Okay, glad to be of help. Okay, let me check the schedule. So webinars, year 13. Next time I see you 2 weeks from now, and we'll do some RLC circuits. Okay, so see you in 2 weeks. Enjoy. Yes, no webinar next week.